Hey everyone, welcome back to our channel. My name is Kende, and today we are starting an exciting series that takes us on a journey from the very beginning of electricity to the cutting edge of technologies of today. If you are passionate about electronics or just curious about how it all began, this series is for you. If you haven't subscribed to our channel, kindly do so that by the time we upload the next video, you won't be missing out. Our journey begins in ancient Greece with a man named Thales of Miletus. Around 600 BC, Thales discovered that rubbing amber with foam attracted very small objects. This was the first recorded observation of static electricity. Fast forwarding to the 17th century, and we'll meet William Gilbert, the father of the term electricity. Gilbert was the first to study the phenomena of magnetism and electricity in a systematic way. His work laid the foundation for future scientists. Now let's jump to the 18th century, where we encounter the legendary Benjamin Franklin. Franklin's famous kite experiment in 1752 proved that lightning is a form of electricity. This groundbreaking discovery helped demystify electricity and paved the way for future research. Entering the 19th century, a period bursting with innovation, Michael Faraday, often called the father of electromagnetism, discovered electromagnetic induction in 1831. His work led to the development of electric generators and transformers, which are still fundamental to our electrical systems today. Meanwhile, in 1821, George Simon Ohms also formulated Ohm's law, which defines the relationship between voltage, current, and resistance. This law is a cornerstone in the study of electronics. Now let's talk about Thomas Edison and Nikola Tesla, two giants whose rivalry sparked the war of the currents. Edison championed direct current DC, while Tesla advocated for alternating current AC. Ultimately, Tesla's alternating current won due to its efficiency in transmitting power over long distance. Now moving into the 20th century, we witnessed the birth of modern electronics with the invention of the transistor in 1947 by John Bardeen, Walter Brattain, and William Shockley. The transistor revolutionized electronics, leading to the development of smaller, more powerful devices. And now, in the 21st century, we are seeing incredible advancement in electronics with the rise of integrated circuits, microprocessors, and artificial intelligence. These technologies are driving innovations in everything from smartphones to autonomous vehicles. So, now let's go back a little to talk about Ohm's law, because this law is very fundamental to electronics. Now, Ohm's law is named after Georg Simon Ohms, a German physicist who formulated it in 1827. This law defines the relationship between voltage V, current I, and resistance R in an electrical circuit. The formula is simple yet powerful. V equals IR, or I times R. Now let's break it down. Voltage, which is measured in volt, is the potential difference between 2 points in a circuit. It's what pushes electric charges through a conductor. Then, current, which is also measured in amperes. A is the flow of electric charge, while resistance, R, which is measured in ohms, is the opposition to the flow of current. In our next video, we are going to talk more about this resistance. To see Ohm's law in action, let's do a simple experiment. Here I have a resistor and a battery. The battery provides a voltage and the resistor limits the current flow. When we connect the resistor to the battery, the current flows through the resistor. By measuring the voltage across the resistor and the current through it, we can calculate the resistance using Ohm's law. Suppose our battery provides 9 volts and our multimeter shows a current of 0.03 amperes. Using Ohm's law, we can calculate the resistance as follows. R is equals to V all over I, which is equals to our 9 volt all over 0.03 amperes, which is going to give us 300 ohms. Simple, right? Ohm's law is fundamental because it helps us design and analyze electrical circuits. By knowing any two of the 3 variables, voltage, current, and resistance, we can always calculate the third. Now let's move on to another practical law, Kirchhoff's voltage law, KVL. Gustav Kirchhoff, a German physicist, formulated 2 crucial laws in the 19th century. KVL also states that the sum of all voltages around a closed loop in a circuit must equal 0. That means in your circuit, the sum of all the voltage there must be equal to 0. Imagine we have a loop with a battery and 3 resistors. According to KVL, the voltage provided by the battery is equal to the sum of the voltage drops across each resistance. If our battery provides 12 volts and the voltage drop across the resistors are 3 volts, 9 volts, and 5 volts respectively, KVL tells us that 12 volts minus 3 volts minus 14 volts minus 5 volts equals to 0. Kirchhoff's voltage law is essential for analyzing complex circuits where multiple components are connected in loops. The second law, Kirchhoff's current law, KCL, states that the total current entering a junction must equal the total current leaving that junction. That means you have a point where different components are terminated. The amount of current coming to that point is the same as the current leaving that point. This law is based on the principle of conservation of charge. If we have a junction with 3 incoming currents and 2 outgoing currents, KCL tells us that the sum of the incoming current equals the sum of the outgoing current. For example, if the incoming currents are 2 amps, 3 amps, and 1 amps, and the outgoing current are 2 amps and 4 amps, KCL tells us that 2 amps plus 3 amps plus 1 amps is equals to 4 amps plus 2 amps. So incoming is the same thing equal to outgoing. Understanding Ohm's laws, Kirchhoff's voltage law and Kirchhoff's current law is crucial for anyone working with electronic circuits. These laws provide the foundation for analyzing and designing all kinds of electronic systems. In our next episode, we'll build more on these principles and explore more practical applications, including series and parallel circuits. We'll also look at how these laws apply to real-world projects. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell so you never miss an update. Thanks for watching, and we'll see you in the next episode.